Our second video on correlation starts with us looking at different kinds of scatter plots. And what we want to do is to be able to estimate what the R value or the correlation coefficient might be when we look at a scatter plot. When we look at this first scatter plot, we see that all these points are in a line. So that means that the correlation should be strong. And it is rising, so that would be a positive correlation. So we would estimate this correlation value to be near 1, and we would say that it is a strong positive correlation. When we look at the second scatter plot, it is also rising or increasing, so we would say it is a positive correlation. We would say the R value is greater than 0, somewhere greater than 0, and it is fairly strong because it does resemble some type of linear pattern. As we look at this next scatter plot, the data is more spread out, but it is somewhat linear, somewhat rising. So we would say that the R value is greater than 0, but maybe moderate to weak in terms of what that value may be. We're not really sure. We just know that it is rising and it is going up in an up direction. So we can't really distinguish what or how well that model may be. When we look at this last scatter plot here, we really can't distinguish a pattern with what's going on here. We could say it's going down, we could say it's horizontal, we could say it's going up. So we would have to say there is no correlation going on in this particular scatter plot. So we look at scatter plots and we can estimate what that correlation value may be without any kind of calculation. Let's look at some more. As we look at this next scatter plot, we see that the data items are all in a line and they're all decreasing. So we would say that the R value probably is -1 since they're all in a straight line. It would be a very strong negative correlation in that case. And sometimes with fewer data items, you can get a stronger correlation than you do when you have more data items. It's easier to get a stronger correlation. With our next scatter plot, it is decreasing, so we would say the R value is less than 0, but it is still in a pretty good pattern of decreasing, so we would say it is a strong correlation, a strong negative correlation. Again, with this one, they're a little more spread out, so we might say that R is less than 0, but again, it might be moderate to weak correlation in this particular model. Again, with this one, it doesn't seem to have any kind of linear pattern, so we would say that that is no correlation in that particular scatter plot. So we want to be able to look at a scatter plot and distinguish or estimate what the type of correlation value may be in terms of linear graphs. So those are skills that we want to be able to do by looking at particular scatter plots. But next we want to be able to actually calculate the value of R, and we do have a formula for it. It's a great big long formula, of course. So we have N times the summation of X times Y minus the summation of X times the summation of Y. And notice it does have some familiar notation that we've used before. And then we throw in a square root symbol. So we have N times the summation of X squared minus the summation of X squared. And then we have another square root symbol where we do N times the summation of y squared minus the summation of y squared. And that's all under the square root sign, and that's all under that numerator. So you know, when we were building that XY table before and doing those calculations, here's where we're going to need that y squared information. So it wasn't for obsolete that we didn't need that information before. So let's look at some of that data that we had looked at before. We had looked at x being and y. We had 3, 5, 0, 1, 2, and 6. We had done this in a previous video before, and we had 5, 22, 7, 12, 20, and 30. And so we want to create, extend this table. We want to find x squared. We want to find y squared. And we want to find xy. And then we're going to want to find the sums of all these. So, first x squared is 9, 25, 0, 1, 4, and 36. Y squared is 225. 22 squared is 484. 7 squared is 49. 12 squared is 144. 2 squared is 20 squared is 400. And 30 squared is 900. And then x times y is 45. 5 times 22 is 110. 0 times 7 is 0. 1 times 12 is 12. 2 times 20 is 40. And 6 times 30 is 180. And then we want to add up all those columns. So we have 17, 106, 75, 2,202, and 387 for those totals. And now we had n equals 6 being the number of data items, and we want to find our value of r. So that would be 6 times 387 minus 17 times 106 over the square root of 6 times 75 minus 17 squared, and 6 times 106, no, excuse me, 6 times 2,202 minus 106 squared. And so r equals 6 times 387 is 2322 minus 17 times 106 is 1802. We have the square root here of 161 and the square root here of 1976. We end up with 520 over 564.07, which gives us 92.18. So, excuse me, 0.9218 for our R value. So this is an R value that is close to +1, so that would say that our correlation is relatively strong.